Hello guys, welcome to this video. In this video, we are going to solve a problem called Kth Smallest in BST. In this problem, we are given a BST and an integer k. The task is to find Kth Smallest Element in BST. And if there exists no Kth Smallest Element present, then we need to return -1. So guys, there are some examples which will help us clarify the problem statement. So for example, now we are given some examples here. We can see. Let us go to the example here. We can see in this first example, and we are given a binary search tree which is 2 1 3 and k is equal to 2, which means we have to return second smallest value from this binary search tree. So if we can clearly see that the smallest value of this binary tree is 1, which is the first smallest value, and this 2 is second smallest value. And this is what our output is. If you see, our output is 2, which means the second smallest value in this binary search tree is 2. We are also given this explanation here, right? Let us see another example. Let us see another example very quickly. So in this example also, we are given same binary search tree, and we are given 3 nodes, right? 2 1 and 3, and we are asked k is equal to 5, which means fifth smallest element in this binary search tree, which we know that the first smallest is 1, is this, second smallest is this, okay, third smallest is this, and there is no fourth smallest, there is no fifth smallest, right? Which means in this binary search tree we can't find fifth smallest number, which means we need to return -1. Since there exists no fifth smallest element, then we have to return -1. This is given in the problem statement also. Take third example. This is binary search tree, and we have to return k is equal to 3, that is third smallest value from this binary search tree. So let us see, what is the first smallest value? Is this one. This is the first smallest value, right? Second smallest value is this, okay. The third smallest value is this, and this is what is our answer. Output is 10, which means this value is the third smallest value which is already asked us. So we are returning 10 here. We are returning 10 here, right? So I hope you guys understood the problem. So let us see some approaches. Let us see the first approach which will come in your brain. There is something called Inorder Traversal. Take example of this tree. I'm taking this binary search tree as an example for our first approach, which is Inorder Traversal. If you guys know that in Inorder Traversal of any binary search tree gives us all the nodes in sorted order. For example, if we find Inorder Traversal of this binary search tree, we would get all of its nodes in a sorted order. Let us see how. First we go left, root, and then right. This is what we call Inorder Traversal. And first we will go left, then we will process the root, and then we'll go to right. This is how we are going to do. So if we start here, this is our root. We'll go to left, okay, left, then left, and since it has no children, we will process it, like left, then root. This is the root. So root, process the root, and go back. We simply go back to this one, and since we have already called, now we will print 8. Then from 8 we will go its right, like this. Into its right, then from right we will again go left. Since 10 does not have any children, so we'll print 10. We can't go any further from 10, right? We can't go further from 10. Okay, next where we can go from 10, we will come back. We'll come back to 12. Then at 12 we will process 12. We have already gone to left of 12. Now root and then right. Let's go to right, and since 14 does not have any children, we can't go left or right of 14, so we'll process 14. We come here and we print 14. We got 14. From 14 we will go back. 12 is already processed, we'll go back. 8 is already processed, we'll go back. 20. Now we came to 20. Since we have already gone to left of 20, so we will simply process it right now, because left, root, and then right. So root will be processed, which means we will get 20. We got 20 here, okay. After 20 is processed, we have already gone to left of 20, we will go right on. and after processing 20 we will go right of 20. We go right, it is right, which is 20, 22, and 22 is having null children. We can't go left and right from 20, 22, so we'll process it. Another is 22. Now if you can clearly see the inorder we have got, which is this, is sorted. All the nodes in this are written in sorted order, which means inorder traversal of a binary search tree gives all of its nodes in sorted order. And what we are asked, third smallest node from the binary search tree. So can we say that this is our third node? We are using 1 based indexing, right? Third node. So this is 1, this is 2, and this is 3. So can we simply return, if we store whole inorder traversal, we will store whole inorder traversal in an array and return simply we can return array of k minus 1. Can we say this? Yes or no? We can say this, right? But the problem with this approach is we are given the space complexity is O1. We need to use no auxiliary space, and here we are already using an extra array to store all the nodes, which means this approach is not going to work here, right? What we need to do is we need to find another approach, and the another approach would be something in which we are not having any extra array or array list to store the nodes, right? So let us go to another approach. Let us see another approach quickly. Let me raise it. Okay guys, so let us see. The another approach is very simple. What we will do, we will start from the root. We will take a counter. What we will do, we will take a counter. We will do inorder traversal and make sure that we increase this count. First we visit left, then we will visit root, left, root, and right. We will visit left, then root, and then right. Right guys? So while doing inorder traversal, we will increase the count whenever we will process the root. And this way, let's say if we process from here, this is root, we went here, left, then left, and since if we do left call of 4, we will get nothing. Then we will do right root, first left, then root, and then right. So after doing left call from the 4, we did root, we will process 4. So how would we process 4? We will do nothing, we will just increase the count. Count is 1 now, right? Count is 1 plus. Next, we will go back from here, we will do right call for the 4 and simply go back. Since right is null, nothing will happen, and we'll go back to 8. Now once we went to 8, we have already done left call of 8, and now we are coming back to 8, which means we are going to process 8, right? Left, root, right. So root will be processed, which is 8 now. So what we'll do, we will increase the count by 1. Okay. And we'll go back from 8. What we will do, we have already done left call. Now we are processing 8, and now we will do right call from the 8. So right call is done. We reach 12. From 12 we will do left call, right? We are doing inorder traversal. Left call from 10. What we will say, we will go left. Left is null, so we will come back from 10 and we will process 10. So for 10, what we will do, we will increase the count by 1. Whenever we are processing a node, we are increasing count by 1. And one more important thing, whenever we will have a if check. So currently our count is 3. Whenever we see our count, if our count has reached k, if our count is equal to k, which is 3 in this case, we will store the current value, which is the current value of the node, which is 10. We will return this as our answer. So we will not just have count variable, we will need extra variable, one more extra variable, which will be called answer, for example answer or kth smallest, and we will store whenever count reaches the k, the given k and count are equal. In that situation, we will make our answer to the current node and simply return it. And in a case when the count variable reaches more than k, which means we have got invalid answer, which means we can't find answer in that situation. So what we will simply do, we will simply return -1 in that situation, or we can simply say that the default value of answer is -1. So if we could find answer, we will return the answer. If we could not find answer, we will simply return -1. I hope here something like at least 50-60% concept is clear. If it is not clear, it will be clear very easily when we see the code. I hope you guys trust me, right? Let's go. Let us see the code. So we came here to code. Let us see the code. We are given this node, right? This is our structure of the node. This is our solution. So we have taken a variable, a global variable, kth smallest, which will be our answer, right? And a count variable to store count of the nodes whenever we are processing them, right? And this is a helper function for doing the whole work. And then we have kth smallest return. We are returning kth smallest here, right? In this given function. So for example, returning kth smallest, because this is asked. Why the kth smallest is initialized by -1? If you ask me, it is because if there is no kth smallest element present, then we need to return -1. So why not? Default value is -1, right? And this helper function, let us see what the helper function is doing. Here we check if root is null, then we can't do any processing. If you know that, if root is null, we can't do anything. So we will simply terminate, right? We are saying return null. Okay. Sorry, return. We are just simply returning from the function. Okay. Then we do left call. As I said, we are doing Inorder Traversal. So left first, then here we are processing the root, and then right call. Left, root, right. This is how Inorder call works, right? And we are doing Inorder calling only because what? Because we want kth smallest number. So we want all the nodes in ascending order. I hope you understand it. So here we are increasing the count while processing the node. We are increasing the count plus and checking if count has reached k or not. Are we in the kth smallest node or not? If yes, if we are in the kth smallest node, we are saying kth smallest is equal to root.data. Our current node is the kth smallest node, and we are assigning the current data into kth smallest and returning, which means since we have found our kth smallest value, we don't need to process further, right? No need to process further. We don't need to go any right subtree call or do further recursive calls, right? We can simply return from here. If we have not found, let's say if k is not found here, count is not k, so then we will do right subtree call. We will go to right subtree, and then again same recursive function will be called again and again, and we will reach our kth smallest value. If we don't reach our kth smallest value, or let's say we are unable, let's say k is too big. This k is too big for example like this, like this. K is 5. We can never reach, the count will never reach 5. Count can never reach 5, right? Before it reaches 5, the whole recursive function will be terminated, right? And we can never find this fifth smallest value. So what will happen? That is why the by default kth smallest value is -1. So if this block is not executed, the kth value would be -1, and we are simply returning -1 in that case. And if this block successfully executed, then kth smallest value will contain root's data, which is the current node's data, which is kth smallest value. And this way, it will return the kth smallest value when it exists and -1 when it does not exist. So let us just quickly submit this code. And yeah, one thing before submitting this code, see the time complexity. Auxiliary space is constant. We are not using any extra space. Of course, there is a stack of recursion, right? But that is tolerated because this is binary search tree. This is a tree, and trees are like by default traverse using recursion. This is the method of traversing tree. So we are not allocating any extra space. In the previous approach, in which we were saving all the we're doing Inorder Traversal and saving all the nodes in an array, and then returning k-1th value, k-1th index value as a kth smallest value in the BST. In that approach, we were using extra space. Here we are not using extra space at all. So this is a fine solution, right? So we just need to submit it. Okay guys, let's submit. Let us see if it runs or not. It will run definitely. Test case processed, and yes, all test case passed. And I hope I made you understand this problem. I hope you have learned something, and I hope you guys like, share, subscribe this channel. This is second video of this channel, and I hope you will provide your feedback. Like, share, subscribe this channel. It will help me. It will motivate me to create more and more videos. And if there are any mistakes in this video, please write in comment section. As I told you, this is second video of my channel, right guys? So like, share, subscribe, and put your suggestion in comment section. Thank you so much. Bye and take care.